from this work, we can see Dobot's history. In fact, Dobot, we started from 2015. At that time, we have 5 persons, including our CEO. You can get it, our co-founders, 5 engineers. And also, Jerry is our Dobot CEO. He started from Shandong University. This is the reason why we put our factory in Shandong, his hometown. But our headquarters in Shenzhen. So, firstly, we developed the small robot arm, Dobot Magician. Yeah, this is the first type of our robots selling to university, vocational school, high school. For example, we can connect with the small robot arm with POC, ROS, MATLAB, LabVIEW, and also use different programming language to control our robots. So after that, we launched the industry robots, especially our CR robots, MG500 and MM Pro. So in 2018 and 2022, we have very honored to meet our Chinese President, the chairman, Mr. Xi Jinping, and show our product to him. And also 2015 and 2017, we have the 2 times to meet our premier, Mr. Li Keqiang, and also with our teams to show our product to our Chinese leaders, and also reported by CCTV in China. Okay, next way please. So till now, Dobot, we have the different products, including the industry, education, and the commercial. So with different price and also different value to our customers. And in past 10 years, Dobot also, we had got a lot of the investors to invest our company. But very likely is that at the end of 2024, Dobot successfully IPO in Hong Kong. So from that time, Dobot is the first Chinese cobalt brand to IPO successfully. Okay, and also in past 7 years, Dobot also ranked number 1 in exporting. That means I believe our partners know many Chinese industrial robots and cobalt, but Dobot, the exporting the overseas market, we are number 1. Yeah. So in past 10 years, Dobot overseas market sales revenue 50%, and China market 50% in past 10 years. Yeah. Okay. So you can see we also put our headquarters of Europe in Germany. In Germany, we will have around 30 to 40 staff, and we also put the headquarters of US in Dallas in America, and also in Japan we have a Tokyo office, Nagoya office, and also in Southeast Asia we have the Thailand office and the Malaysia office, and in this year we will set up the Korea office and also India office. Yeah. So this is our sales network to the markets. So you can see Dobot pay very high attention on the overseas markets if comparing to our other competitors. Okay, so this is my brief introduction about Dobot history. And next part, I will introduce the Dobot products. Okay. Okay, this way, please. So Dobot, just now I mentioned we start from the small educational robots, because we hope the students in the schools, in high school, university, they can learn our robots. And they can learn the programming, they can learn the robotics, they can learn the POC. So after they graduate in the enterprise or factory, they can use our industry robots. So this is our ideas. We hope we can set up our ecosystem. So in industry robots, we have the big one, also the small one, okay? And at the same time, if you want to use in the commercial use, we can use the low one. Like just now we say it's making coffee, making noodles, or in Southeast Asia, we can use it for massage. So you can do a lot of applications. So and also we have different successful cases. For example, this picture shows we used our robots in luxury ICT, and they used more than 250 CR robots, and in China factory and also Vietnam factories, and also this used in US, and we cooperate with KFC and Coca-Cola, and in Coca-Cola they can making the Coke, and also KFC maybe making the fried chicken and also some potatoes. And this page used in the India last year. They used for the surgery, and last 2 years they had used more than 300 pieces CR robots in India successfully. And also we had used in the robot competition WRCC. Yeah, so this is Dobot some applications. Maybe later in our training room I will make some detailed introduction about this part. Okay, this way please. So, Sharon, 这里来讲一下。
Okay. This one you saw is our take AI technology, which this platform is for egg trainer. But the whole egg trainer, the basically concept is we have per eyes, we have two vision for more accuracy about trajectory, and two slaves robots, and this is for master hands. The first thing is we can gathering all the data recording by master hand, controlling the robots. Also the video. The next part is we can directly sending those data like this, sending to the AI. The AI will be doing the mimic, like imitate what kind of operation you make. For this one is a simple concept about making something like a laundry, make washing the dishes. For example, we take some ketchup on this plate. On the dish, I put it in here. We can get this in the camera. Yes. While the robot see the cameras, he can directly go here and to check the location where we have trained for. After maybe 2 or 3 hours training, we can run the inference like this. And here, he will be examined if there any ketchup, any dirty part. We'll be knowing if I need to wash this or not. Meanwhile, you can see the gripper part. We'll be washing everything 1, 2, 3 like this, then check it again. So the whole part actually is not for programming. This whole part we make is the AI doing its own logic control. We will checking if we need to do this, where is the sponge, where is the dish, and after we wash this, where we put the new dish, like clean dish too, something like this. The whole part we'll be checking again if this part is okay or not. Sorry. From here, I think this is a little bit clinch. Yeah. Sometimes the sponge, we need to wet the sponge before, but today it's so dry. In the source of China, if you don't clean this, we will have a lot of cockroach. And if we do this like with a clean dish, also you can see here, we will be checking the results from here. This is our programming interface. You can see this how it's running. And we give this one will be exam in the real time to think if this one, what should we do for the all logic control by itself. And this one we check is clean, then we directly go there. So this is how the X trainer moves. Basically, this is the same concept like a humanoid upper body, or we can call this like a humanoid upper bodies, like prototype. And later of this, we have doing more development and researchment for the humanoid. We call Atom series. And for this time, I'm really unfortunate, like on Thursday, like last Thursday, we put the Atom go there for upgrading the system and algorithm system. So we think maybe take 3 or 4 days, came back to here. So far we can check the video, okay? Thanks. And here is the video. We're doing the tele operation about the operation of robots with VR system. You can see meanwhile, all trainer in Shenzhen, in this city, And this robot in Shandong, in our factory city, about thousands miles away. We're using the internet by VR system, connecting, getting data, sending real time. You can see the fingers. This part will collect all the fingers data, how you running the fingers, and how the necks move, how the hands move, everything. Basically, this is the same concept like X-trainer and Atom. They share the same concept. And for here, about Atom's total body, we have 41 degree of freezer. About the arms, fingers, and legs, and the feet. And here, we have 2 cameras for eyes, VR control, and deep camera for AI learning. 2 cameras in the arm for the more accuracy. This is a simple presentation about the robot doing delivery job in our office. This is our 24th floor office, we just saw it. And we're using these robots, we also go to the China, CCTV, Chinese, like a national television. This part is that's our CTO, that's it. He introduced our robot making barbecue in real time in front of the television.
Wow.
You can see this whole part. While we're moving it, you can gathering like where is the chili, where is the meat, where is the cucumber, blah, blah, everything, and brush the piece. I think brush piece is the next step. So basically, this whole movement is for self-learning and AI technology control. Our humanoid is not for dancing or something. We are doing the simple application. We're doing something like a labor for humanity. Okay, just like this. So this whole part will be concept. In here, they have we call the microphone system. He can listen to your like a voice control. You can give some simple command to the robots. If after you train the robot, he can learn what kind of command you send to it, and he will do everything by himself. And the next part is in the middle of the head, in that part, like below the jaw, we have a 3D laser. He will be walking through the whole room, scanning a 3D mapping. And in that term, we can tell the robot, like this is maybe a lobby, this is maybe desk 1, desk 2, and we can tell the robot, go to desk 1, give me a card or something, he can understand what kind of command you give him. But we need to train, of course. This is the thing we just thought. 那个啥那个，现在我是不是得那个调一下那个啥？我记得是这个或者这个啊？不知道这啥？真的？哦，真的。哎，为什么？哦，弄错了。是，是不是得好像是到那个 H 就这个，就这个。Okay, now everyone, we are going to introduce you about Hexplorer, a 6-legs robot. In this term, you can see the robot doing the delivery job. This robot, we have, the first thing you saw, we have 6 legs, really flexible. The second thing is we can carry, because we have more legs, we can carry far way more payload than the other, like a 4-legs dog, which we have 20 kilograms payload ability. Yeah, 20 kilograms. Carry on the back. You cannot see him on it. Thinking about it will crush it. But if you do something heavy, it's okay. 20 kilograms. This is showing you about ability. You're walking through different stage, different like playground or something. This part is climbing the stage, and again something like a bar, and even go to somewhere with the bird. This is the whole movement he have, and also he has the ability about because you can hear the voice. Actually, this voice is not really loud. It's, we can walk into the library or something. It's really silent. And for those parts, we can have another interface for making some cameras, making some small robot arm on the tail of the robot. This is walking through the web ladder, and this is walking on some unstable plane. And this is we're doing the inspection in the parking land. And this is we walking through the wild place against the ground. So which make this robot have more ability about like a different place, and we can make this for some special task. and he got more stability than usually 4 legs raw dogs. Every time we have 3 legs attached on the ground, so triangles make it really stable, even on the side kick or something, it should be fine. And we also have a small 4-leg dog, but we don't put it here. There's another small product. This is another type, we call it Roar X1, and he will be in this showroom, I think, maybe I expect in the next months, I think. But this whole part, the first thing is we got the cameras like this. The cameras get the 3D lasers, and the second part is in here we can carry something with a picture, and we can put something like a cameras on the top of the robot part, on the back basically, and just like this. And also you can easily to fit something like a plug and place wheel doing this whole training, and can automatically avoid like your penetration or there is something blocked on the way. And also we have the voice control, and you can, when you're walking, you can tell it's like following, and this robot will following you and take a picture or make a video for you for a vlog or something. Just like this. Okay, this is embodied AI and technology part. This is the 3 major product we have. Thank you for your attention. Thanks.
Thank you. Wonderful. Any question?
For this part is another technology we're using to getting the real-time trajectory. Sometimes we're using robots doing program, but you need to make a lot of points for a simple trajectory. But for this, we have a new technology. We can get in this whole trajectory really easy and in real time. This part is we are going to, we have a 3D cameras here. You can gathering the coordination about the end of my hands tool. And here is the starting position. So basically, we need to do is we make sure every movement in this range. And another part is we're going to writing this. So he will be gathering the data and running with my finger at the same time. Sorry, my writing is not good. Okay, at least I do my best, okay? Maybe it looks ugly. Sorry about this. But basically you can see he can try to imitate like what kind of trajectory and movement you made and copy back to itself. Basically this is the same idea. In the lobby we have a copy machine, like doing the copy art. We're getting the real-time trajectory from the real copy method. How we make this and doing this, everything, and then robot can make the same thing, exactly the same thing in the lobby, just like this. So this whole technology, we can also getting this data, you can see here, this is the workout, the whole trajectory, and later you can send this trajectory to the robot itself for self-warning, like this. Thank you. Thank you. The whole those part came from the simple concept of how to controlling your drive, how to controlling your like the software real-time system. So this part is about the driving function. You can see below is an ordinary PID driving about running accelerate speed, average speed, and then speed up and speed down, something like this. So you can see that it's shaking, kind of unstable. And here we're using the vibration suppression algorithm system. We can check the whole liquid of moving. We can make sure the robot's moving smoothly. Sure. And here is based on those technology, making the CR5 robot like this with we call this a force control function. Here we have a force control, a force sensor right here. While we're running, we only teach a robot from here to here. We got the 2 points. Also, we need to running in constant force. And he will be running against this surface. And if there is something like force, he will also following the whole position like this. See this? This whole part is the first thing is about the driving and about the trajectory algorithm system, about tooling. And in Dobot, we have doing the researchment and development for every component inside of the robot. And in the robot itself, we have a controller cabinet like this. We will have a simple training on how to maintenance and replacing those components in the next week. This is from the controller here. And controller's system board, server board, and that's it. And the main PC right here. And this is for the joints, every component inside of the joints. This whole module and the encoders, driver system we made by ourselves. And for this part is another new technology. We call this e-skin. E-skin is for the electronic skin. It can sense you before it touches you. Usually the common robot, it will like this robot hitting on you, it will stop. But it's after it hitting on you, after the collision. Kind of not really safe. So this product concept is we are going to using this. You can avoid you at least like 15 centimeter. In here, if you pass away, you will try to avoid in every direction. Once you touch, stopped. So this will be making the robot more safe than the other products. And for this part technology, we use this for a lot of education purpose. You know, some kind of kids will be hanging around, and for some like a really safety concern factory. With this, we don't need a barrier, we don't need a laser track. We just take this, and the whole working range actually will be really flexible. It can directly be working with me. Like none of the worker will be worried about the robot hitting on you or do some damage on you. And if he does, just touch it to the stop directly. This is how e-skin works. For this part, it's telling you about the robot sensing. This 3 volt about the sensing. This is for touch sense, and this one is for the audio sense about the ear. This is the skin, this is the ear. 给我一个苹果. So basically, we told the robots like, give me an apple. Give me an apple. Here, we'll be checking where's the apple in the dish, and grabbing it with the electronic suction cups, like a flexible gripper, right? And go there and put it here. If you told him give me 2 apples or 3 apples, he can count by himself. This is the concept for robots ear about our voice control. Here is the prototype for 2.5D cameras for vision, like skin, ear, and eyes. So this part we can automatically grabbing something like different shapes and different angle, like this. And after this, the robot will check which is the best strategy, which is the best one we can take first. Like this. For whole this part is about the robots, how the robot sensing with a different integrated with a lot of different tool, equipment for doing this. So this is the main technology about the robot arm itself. And a lot of like this we can for the grippers, leg grippers, and some of the vision. We have a standard vision. We don't need an extra cable, just directly attach on the robot end, on the wrist part of the robot, then it's fine. Basically, like that is the prototype for the vision camera. This is our standard camera. This is the standard camera. We call this 2.5D VX500 cameras. It will be have multiple like camera itself, learning the like a 3D gesture about the robots. And this part we can directly attach on the robot end here, and the gripper attached to here, and everything in this like we call this module, like a vision module. Put on here, everything is fine. This is the prototype. You see. The goal for whole concept. In that terms, we don't need extra cable on arms. In some clean room application, like a food, like a semiconductor, we can use that product around it. And here is the structure and the product. That part is our industrial, we call the CR series, collaborative robot series. This part we usually for also industry part. This too is for like a SCARA, for existing robots. And this one is a Magician E6, we're using mostly for education purpose. For this whole part, you can see the first thing is this is really tiny. And for some education purpose, you don't need an extra controller box. this in the bottom. This, you can see that? This is a controller box with the robot itself. So everything will be in this one box. You getting this, you will like basically the same size as a shoe box, something like this. Also like an M1 Pro and MG400. The controller is also like in the bottom of the robot, like this. So everything will be really modularized. And this is Dobot's rules, like the whole structure, how we assemble these robots. And in the next, like I mentioned, in the next week we are going to assemble one of the joints and like this for maintenance purpose. Like this is about everything. For example, from the server board to the encoder, we have two encoders: inner encoder, output encoder, and about this is a brake part for the motor, for the gear, for the bearing, and everything. And this is a hollow cable. The cable will come through here with a power supply, with Ethernet cable, everything. So basically, we modularize the whole thing. Sometime in the future, if you need maintenance, if you need something like a repair, you can directly get in a new module and maybe 20 screws with one cable. That's it. You can easily do repairing about this so modularized product. So this is the basically product concept for Dobot product. Thank you everyone for your time. Thank you. Thank you. The next one, please. This one, James.
Apa?
Make sure stand ni dalam bridge sini.
Okay. Dalam ni lah, jangan tekan draw.
Jangan tunduk.
Waiting. I show you one track.
Yeah. Okay, you show me.
Like this.
But I have to put
Okay, you boleh try.
the nip.
Just boleh.
Tulis Sarawak skill. Sarawak skill.
Boleh.
Daripada sana, Sarawak skill.
Boleh.
The pen and this we have me at this paper. Yeah, you only can write in this paper.
Dia limit dekat table ni saja. Kalau you nak continue dia nak reset.
For the original position.
letak balik.
Yeah. And start.
Boleh continue.
Continue. Yes.
Sebab tadi out of
Keeping the
range.
pen and the paper.
Range dia tertolak tadi.
Perfect.
Thank you.
Is it a company?
Yeah. It's in Borneo. Borneo Island.
It's near to Indonesia.
他怎么写的？机器人就跟着他怎么
It's another side of Malaysia.
那个人怎么写？
就是我们有马来半岛嘛，然后它是越过那个大海大西洋我们两个州都是越过一个大西洋过去。Pinang.
For metal processing and for chemical is usually for some batteries and colors. And this part is for new retail. We make a lot of collaboration with those retail company. And the next part is for medical. We just win a huge order from a major surgery robots company doing this. And here is the real-time CCTV in our factory. So, simple introduce about factory. This is in the real time, so you can directly see how they work in this time. This, you can see the 6th building in here is our robots yard, including the maintenance, assembly, testing, and the secret labs, and storage, everything here. And this is the main building. Here is the testing robots. So for all those robots, they are doing every robot will be doing the testing at least 32 hours. 72 hours. And everything will be running with the full payload, with the full speed, continually running, and we're checking every parameter fit for our quality, then we ship it out. And here, I think they have some lagging on the internet. And here is the QC control place. They will have the components before assembling the robots, checking the quality, checking if this fits for our standards. And then we go to this smart library. This is like a storage room. Whole storage room, we only take 3 guys, contains 3 guys running everything. Because everything we connecting to the internet, and we take this in, our system will decide where this thing to go and how many we have, everything in the system. Like a smart factory, the whole system. And also on the here, this is the production line. Actually, you can see those things, like automation equipment. So far, in here, you can see the robot arms, the bottom of the robot arms. So basically, we are using the robots to like assembling and making the robot itself, just like this. And after this, we take the robot for testing, and then we get the testing results, a good robot in the storage room, waiting for delivery. So this is the real-time camera for our factory, like this. And thank you guys for your time. We're going to the next video, please come this way. No, sorry, next floor.
You spend a lot.
Just 9 RMB. Factory 53,000 square meters. And also bigger than Jakarta Oppo factory 3 or 4 times. So this coffee machine, we can choose different coffee, latte, American coffee, cappuccino, and also you can use the 2R to do the latte art. Yeah, so later we can closely to see. Yeah. see those. And then you can see the latte art. Please. We can have a photo here together.
One is the loneliest number that you'll ever do. Two can be as bad as one. It's the loneliest number since the number one. One is the loneliest number that you'll